Now I'm sufficiently disturbed by this inability to reconcile what I think I see and what I think I understand with a result that we just got that tells me that this curve stops rising some point around here. I'm sufficiently disturbed by that I'm going to be driven to desperation. And in desperation, I'm going to parameterize this curve. X of t is cosine omega t, y of t is 2 sine of omega t, and z of t, which is x squared plus y cubed, is, as we've seen, cosine cubed omega t plus 8 sine cubed of omega t. I think I said that right. Anyhow, it's written correctly. The desperate measure here is that I want to calculate the curvature of this thing. Now you probably have an inkling of what's coming. I'm going to let r of t then equal cosine of omega t I plus 2 sine of omega t j plus cosine squared of omega t plus 8 sine cubed of omega t times k. Now I'm not really going to work out the curvature of this thing. I could do it. I'd probably have to do it 2 or 3 times before I did it without making a mistake, or I'd have to work through it really slowly. That still wouldn't save me. I'd make a mistake. I could put it into a computer algebra system and work this out, let the computer work it out for me very easily, and that wouldn't be an inappropriate use of a computer algebra system. The scheme, though, is familiar and straightforward. We calculate the unit tangent vector, which will be r prime over the magnitude of r prime. Take the derivative of the unit tangent vector with respect to t, and that's going to be r double prime times the magnitude of r prime plus r prime prime magnitude of r prime prime, the prime of the magnitude of r prime times r prime, all divided by magnitude of r prime squared, and that's going to be a rather disturbing algebraic expression. What we would gain from the expression for the derivative of the unit tangent vector, though, is a couple of things. Well, one, we don't really need to use the unit tangent vector. We can say when r prime has a 0k component, the curve stops rising. This is actually an if and only if statement. R prime has a 0k component if and only if the curve stops rising. And we can kind of obliterate that comma there. If that occurs for t equal to 1 over omega times the inverse sine of 1/12, that confirms that this curve stops rising and maybe gives us some insight into the behavior of this approximate graph that we've drawn, or into the behavior of the actual graph that we've approximated here. Now r prime has a 0k component. We'll note if our test would really be that r prime dot k equals 0. The other thing we can get if we have the derivative of the unit tangent vector, we can divide that by the magnitude of r prime and obtain an expression for the curvature. and figure out what the curvature is at this point, just how rapidly is the function curving when we're up at this top point.